Chapter 7, we're going to be working with the strings. We have seen character types. There are various different character types. There's char, white char, char 8, char 16, char 32. Those all characters. And then, of course, to represent a string, we have learned also the C-style strings, right? The null terminated char arrays. And that is sort of the, again, that's why it's called the C style. This is how you represent strings in C. Now in C++, obviously there's something better we can do. And so that's called strings. Now string is not a fundamental type. It's it's like a container. We talked about container before. It's like this is a data, this is basically is a data type that contains um, a char sequence, a character sequence, okay? And the string is a class in the standard namespace, so std : string. And just look at some examples how to create a string object. Now, when you look at this though, when you look at this object, by the way, I use this term, haven't really explained too much about what is an object. An object, so an object in C++ is not the same as an object in, say, Java, if you know Java. An integer, let's say you have a variable of pretty much any type that is an object in C++. Most things are objects. Some things are not objects. For example, a function is not an object. But again, if you declare a variable that points to a function, for example, as a pointer, then that's an object. Now, a type is not an object, or the enumerator in the enumeration type that we studied, the enumerators are also not objects. So there's very few things are not objects, but it's not so important. So kind of we use this term objects to refer to most things in C++. And this string, by the way, it's a class, and then so that's for those that folks that actually come from object-oriented programming languages. They're purely object-oriented programming, for example, like a Java, for the most part. When I say purely, there's also functional programming paradigm in Java now. But the thing is, those are objects. Yes, you instantiate an object of a class. And we're going to study class, next week. And so this is how you may sort of initialize or create an object of string. And by the way, if you don't have the initializer, the curly braces initializer, and then you just declare, let's say, a string proverb, a semicolon, and that's empty string. And why is that empty string? You say, well, when you declare a variable, you should initialize it. Otherwise, it may be a random value. It's not a random value when it comes to class objects. And the language is going to say it's going to do the default initialization. Default initialization is a term for fundamental types. There are indeterminate values, whatever is in the memory, unless you initialize it. So for a class object, it's different. It's actually going to, again, the language detail is a little bit more involved, but generally speaking, it's going to find use the default constructor. So the class has a thing called this constructor that tells the compiler how to construct an object. So the default behavior is sort of defined by the class itself. When you don't have the initializer, you declare a variable of a class type, and then that's going to do the default initialization, which will, if you have a default constructor, is going to do something like that. Okay. So in the case of string, it makes an empty string. Okay. Now, here we are initializing this particular variable, proverb, with a again, this is already familiar to you, right? We've seen this. So this is a string literal, and this string literal is a no terminated string. Okay, it's a no terminated C style string. And of course, it's a constant. It's non-modifiable. And this is used to initialize. By the way, when you do stuff like this, C++ is very efficient. It's not going to do a copy of this situation. For example, this is um, internally, it's going to just hold on to that constant, actually, or making a copy that's in a very efficient way. Um, but the detailed implementation, okay, the implementation could be up to the compiler. Um, but just kind of uh, generally speaking, don't worry too much about performance unless performance becomes an issue. You do profiling, but when you're programming, don't think too much about that. Go for clarity. Okay, make your program more readable. Then here is another style of initializing a string object, and you're creating an object with another string, string object, proverb, and you have two numbers here, two integers. One is this first one usually is represented when you see a pair of integers like this in the context of many of the functions you see in string. The first one usually is the index, like where it starts. The second one usually is a count, like how many characters you want. So this is saying starting from the 0th character, right? And then count 13 of them. So I want that substring to be the phrase, okay? So let's take a look at the an illustration here. So this might be what looks like in memory, okay? We're using this sort of um, simplified format to show what might be in memory. So you have this proverb that has these words, right? Many a miko makes a muckle, right? It's like a tongue twister. And so the phrase is initialized as a substring of this bigger string. And so you're actually gonna get 13 characters as specified here as the count. And then starts from the 0th character, which is starts from M. So essentially that phrase is gonna get many a miko. That's counts as 13 of them. So that's really what is happening. Okay. There are, of course, many flavors of uh, making a string object in the vocabulary of a class. We're going to study class just next week. It's the constructors. There's, you want to see what you can do, you look at the constructors, and you go to the reference. And here's the reference. That's just going to go there right now, right? Go to the CPP. I have this bookmarked, and I'm going to search call a string, and then std : string. You see there's other things showing up here. This is the type we're looking for. And interesting here, actually, you see it points to basic string. Yeah, the actual type um, is a basic string. Why is that? Again, see here, you see in templates, and there's a bunch of things that we have not studied yet. Well, very soon we will. This is a class template, and this class template takes a char type as a parameter to the template. In the case of string, essentially it's just a alias. Okay, it's like a type def or using uh, alias. And that string type, what you see, is essentially a instantiation of this particular template with a char type for the individual characters. Okay, and then you see there's other things that you're familiar. There's a white string. There's basically a double char, white char, char 16, char 32. If you're using those character types, and then you get some other an alias, just something that's shorter because they're so common. You don't want to type that long thing. That's why the standard defines those sort of shorthand types. Okay. So the functionality of a string is the same thing as what you see here in basic string, knowing that the char type, character type is a char, right? Which is a fundamental type. And there are other things you're gonna just ignore them for now. So when you read these things, though, like at this point, you may find it a little difficult to understand everything that's going on. There's a lot going on, right? But hopefully by the end of this course, you're gonna be able to understand most of them, and you should not have much trouble understanding what's going on in the reference and be able to read them. So I just want to point to that. Okay, we're looking at how to create a string, right? So how do you find that out? Because I mean, I may not be able to remember. You can use a couple very common ones, and then if you want to know the exhaustive list, all the different ways of creating a string, you look at this constructor, which is a link, goes to another page. Let's click on this constructor. Look at how many are there, right? Look, there's 11. There's 11 forms of constructors. Okay, this constructors is telling you exactly what you can do to create a string. Um, have all kinds of arguments you can pass in. So as an example, so what we're seeing here, for example, this one, we're initializing with a C style string, right? So this is which one would be this one? So let's take a look. Um, well, actually, this would be the one. That C style string. C style string basically is as you know, right? That we studied the pointers, when you have a C style string, um, you can um, assign a C style string to a char array, right? And then a char array is almost equivalent to a pointer to char, right? Remember the name of the array is like a const pointer, that a pointer that cannot be changed. So the type in this case, this you see a const is basically a pointer to a const char, and of course this would be pointing at the sort of the first character in that no terminated string. So this would be the form that you see here, and then you notice, okay, well here this is like a function call with a parentheses, but then what's going on with this curly braces? The curly braces is the uniform initialization or braced initializer. It's a C++ standards attempt to unify the craziness of initialization, all the different ways, try to create some kind of uniformity. So there are rules on which constructor is going to be chosen. That's done by the compiler based on the arguments that you put in. So in this case, the no terminated string that you pass in is going to match this form of constructor. So this will be chosen to initialize the string, okay, to construct the string. Now, there is another thing. Now, I don't want to complicate the situation a bit further, but there's a thing called the initializer list. Initializer list is a type that actually takes, you can invoke, like you make a string, then you can pass in a curly braces that if what's inside are character types or things that can be converted to characters, then it's going to match this form of initializer, okay? And the book actually has a more detailed explanation, but it does not tie back to what constructor. is going to be invoked, and this is really what's happening behind the scenes. So we're going to study classes, and the things will become a little more clear, right? And for example, this form of an initializer with a string, and then you got two integers here. So this is also is available here. Let's see, right here, this one. Okay. Well, actually not this one. This is deprecated. And when you see this notation here until C++11, so it's done. And then since C++20, let's say this is the one we'll focus on. So essentially, you're gonna look at this particular one. Well, actually, no, hold on. Until, okay, this is not the one. It's position and count. Which one is it? Okay, right here. Okay, this is the one that will be, yeah, this is the one that will be matched. If we're compiling our program with the C++20, and this is what we're really studying. And so you see the first parameter, first argument, right, or parameter, when you talk about the function or declaration, this is the parameters. When you're invoking a function, you're passing in the arguments, okay? So that's kind of a little technical difference there when these two terms was parameter versus argument. Now, so the first one is another string, and look at this thing. This is a reference, right? We studied a reference. It's like an alias. And then it's actually a const reference, okay? And then the second one is the position, where to start picking the substring. And then there's the second number is the count, how many, okay? And then the last one that you might notice, okay, there's a lot of functions that has this thing called allocator. Okay, so let me just a few words on allocator. By the way, here you see this assignment here where the allocator basically creates a default allocator. Is going to have a default allocator if you don't specify it. So this particular parameter is optional. Okay. And by the way, this thing about allocator is kind of the messiness. It's not done very well. There's actually a very nice talk by one of the guys that actually designed the, okay, first of all, what is allocator? Allocator. We have heard this term a little bit, not allocate, but allocate. That's the dynamic memory management. This has to do with, let's say you want to manage the memory block yourself. Like say, okay, you don't like how the standard does it. And maybe you want to, because your mission critical application here, you want to have something, much more performant because of your particular way of using it. You can have your own allocator. That's an abstraction of how you want to manage the memory inside this string container, okay? And you can then manage, you want allocate, deallocate, use the mechanism you like. If one of you is interested in knowing more about allocators, and then I can refer you some resources and you can look into that. But just kind of know what this is. Most of the time, you're probably not going to use it. This is a little bit advanced topic, right? So that's, again, you need to know what they are when you're reading this reference documentation, because otherwise it's like, okay, I can't understand this thing, right? Okay, those are the constructors for creating string objects. Now, let's take a look at the commonly used string functions. Of course, the type doesn't do much if you say, hey, there's nothing I can do with it. And then, of course, it supports a bunch of operations. So I just going to list a couple of them, and the book has more details talking about them, a lot of them in details. And even the book is not exhaustive list. If you want the exhaustive list, go back to that basic string. So that basic string that you'll see as the member types, those are the types, the functions. Okay, we'll look at the functions, and then you have a lot of the stuff that the book has talked about. And actually, for any one of them, there's a sort of multiple formats, sort of multiple versions. See, look at this insert member function. Okay, there's like 11 forms of It's crazy, right? So that's what the standard library is, and so there's like so many. How can you remember? You can't. So most likely you probably have a couple of favorite one, your favorite sort of a forms of a call, and then you sort of know, and then you go. That's your go-to. But of course, and then you're not going to remember. Okay, what exactly what form you're going to use, and so when you encounter a particular situation, and then you look at the reference, and then, okay, here's the thing you can do. Okay. Or if your IDE is good enough, the IDE may make suggestions if it's got the sort of intelligence. And so this is a way you can find. Now, why with this one function you have so many forms of ways of invoking it? And these many ways of invoking the same function, and then we're going to talk a function basically next after this chapter, and why. Okay, how this is called a function overloading. Again, it's not a fancy term. It just means like you have so many different functions. They're actually different functions, but they are grouped together like a family of functions because they all call the same name. They do the same thing, but then they take different parameters, okay, to be useful, to accommodate all different scenarios. That's kind of, as you see, the standard grows and grows, and over the years, it's added so many things, okay? So this is like an exhaustive list. This is the standard. And we're going to also just kind of quickly go through some of them. For example, you have this capacity functions. And by the way, when you see these functions, these terms, the way the standard library is designed, those function names are also standardized. In terms of convention, you're going to see a lot of those names in all the other container types because they settled on having this uniform naming of things. If you see these names on different containers like a vector, they will mean the same thing, basically. So capacity. Empty is not to empty the string like deleting everything. No. This is checking if the string is empty. Is it an empty string or not? That's what it does. It returns a boolean. Length, the how many characters are in this string. That's the length. So length is a more natural word to talk about string. And then there's a more common function in most containers like a vector. It's called a size. We can talk about the size of an array or size of a vector, but typically what they say is don't say size of string. It sounds a little weird. So that's why it's like an alias, another function. It's called length. And then to access the individual characters or all the characters. So, so first I'm going to start with this operator square bracket. This is the subscript operator. Do you remember there's the built-in subscript operator for array? So here, this string basically has this operator overloaded. Okay, we're going to talk about operator overloading probably next week. And so for this particular custom type, this is not the built-in, right? This is a library. You can make your own, and you can do the same thing, overload this subscript operator if it makes sense for that type. It has to be intuitive, right? Otherwise, it just confuses people. So, of course, and then you put an index in here using this to access. Let's say you have a string proverb, right? The verb we defined before, proverb, bracket 1, closing bracket, and that 1, that's the index at position 1, right? Remember zero-based, that goes with everything, right? Array zero-based, the same thing with when we talk about indexes everywhere, it's zero-based. And so that would be the second character in string that you're trying to get. Or to modify, this allows you to read and write. Now, there's also this add function. The add function is not too difficult to guess. It kind of does the same thing as this. although this is not an operator form, like it looks more intuitive than this. However, this does have a one advantage. It does the bounds checking. Bounds checking, what does it mean? So here, you may provide an invalid index. For example, -1, then that's an invalid index. It's out of range. You're going to get an exception. We're going to talk about exception later on, 2 weeks later. But it's an error, right? So, but here this at function is safer. It will do the checking. It will not, sort of raise an exception if uh, that's basically what that function, the difference between that. So you can also retrieve the underlying, as I said, internally. Well, I guess I didn't say it, sorry. So the string actually internally maintains a C style string also. This whole char array, null terminated, is in there. But it's encapsulated, you cannot access, it's private. So the you can use this data function to get access to that char pointer to char. It actually returns the pointer to char. And this is the difference between data and the C string. Of course, this means you're returning the C string. The C string, it returns a constant. It's a pointer to const char versus the data is a pointer to char. So this allows you to modify if you need to, and then this one doesn't, only allows you to read only. Now they are there because you need to be compatible with some old library legacy code. For example, they only take C style string, perhaps, and then that's the place where you might use this. Otherwise, just use string all the way through. And then there's a couple of read operations. You may say, okay, is the string starts with a particular character or starts with a particular word, right? Checking the beginning of the string. And then you also can check ends with, was the last couple characters, right? And then you can use the substring to retrieve a portion of the string anywhere in the string, basically a range of the string characters to retrieve a substring out of it. And then you can have the write operations with the insert. So you can actually insert characters or strings into the string. You can erase, of course. Erase means to remove them, one or multiple or range of them or wherever you want to remove from. And you may replace. So remove a portion of it and replace it with something else. You may append to add something in the end of the string, okay, to lengthen it with something else. And then you also have this another operator that's overloaded. Of course, we know this is a compound operator with a addition, right? So here, of course, the meaning of that operator is redefined for string type. This is for concatenation. Concatenate to basically put two strings together, okay? Very useful operator. It is intuitive when you use the plus, right? String 1 plus string 2, that's very intuitive. And then you may also want to search, okay? Typically, if you have string, one of the common operations is to find stuff in the string. So you have this find, reverse find the first of something, find the last of something. I mean, you use this a lot if you're reading a document or reading an electronic book, and then you find, right? Find stuff, and that's kind of the idea. You may also compare string objects. Now, this comparison function returns an integer, a signed integer. If it's a -1, it means let's say you have a string S1, you use the compare function, you compare with another string S2. So if it returns a negative and then S1 is less than S2, okay, what does less than mean in string? Less than, greater than is based on dictionary order. or the fancy word is the lexicographical. I believe that's the word. Anyway, dictionary order. Okay, the letters based on the code points in the um, specific uh, the code, the encoding, well, the the code point in that if it's ASCII, it would be ASCII, the character set, or it would be a Unicode, and so it goes by that. And then the spaceship operator or three-way operator. So we have studied this before. This returns an object like a weak ordering or strong ordering, and that basically allows you to only compare once, and then you can use the result in multiple places. That's kind of just a little bit of efficiency that way. And then you have conversion functions um, from one type to another. So here, what you see, this is a as you see the naming in terms of the standard library, that you see there's the committee is very economical about using letters. They don't want you to type a lot, right? That's kind of, you get the feeling, right? A lot of the abbreviation, you're gonna see them. So this means S is string to integer. Okay, I stands for integer. So you can also have conversion functions like S to long, 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 unsigned long, unsigned long, long, right? Flow, double, long, double, right? Those are the fundamental types. And then you can also have to string, means you're going to convert a number to string, an integer or a floating point to string. Now, if it's a floating point, the precision is fixed to be 6. If you want something different, use format, right? We have studied format. Then they will format whatever number however you want. So as you know, the format function returns a string object. Okay. So it also supports some I/O functions. I/O, basically if you were gonna print out the string or take something from input. So of course, so it supports these operators. The stream insertion, stream extraction, right? So we've seen a lot of these, C out or C in, and get line. So you have seen examples where you can read a number or a word. And then as soon as you put a space, then it will kind of take the space. That's kind of default behavior with those. But what if you want to get a whole line of things where it may contain spaces? And so you can use this function, get line. Then there is also something else. So if you remember the string with the double quotes, that's a null terminated C style string. Now, you could have a literal string with a double quote, but then if you add s toward the end, a suffix s, that makes that turn that into a string object. Okay. So this is an interesting thing here is that this is also an operator. So it's a suffix for literal. And this is kind of the format it may look like. And we're going to study more about operator overloading. So as I said, the complete spec is on CPP reference, and you can go look at them whenever you're in doubt. There's another style of string literal. It's called a raw string literals, and there's many programming language actually supports this, right? So when you have a block of words, you may have a poem. This is it would be very difficult if you have to use many strings and then they're all just limited to one line. So when you have multiple lines, not only multiple lines, let's say when you have characters that are going to be typically they're reserved, they have special meaning in the language, Normally, you would have to escape them with a backslash for some of those special characters. But if you don't want them, then this is a mechanism to allow you to import whatever you want as a raw string. The compiler is going to treat this thing as is, including the new lines, spaces, everything will be preserved. Okay, so here's an example. Anything that's in between this example parentheses, okay, and then closing parentheses, and then the example, that sequence. So the reason it has this sequence is if I have other parentheses inside, and as long as it doesn't match that sequence, ending sequence, then you're fine, right? So that the compiler can recognize where does it end. So I use here to put in some C++ code in here as a raw string. So it's very suited for this. Okay. Now is the time to actually look at a little bit of code. So an example, 703. So the string functions, all this, the type, and they're actually in this particular header string. So here, let's say we have a vector of a string. And now remember the vector. I can take any type. Well, just about any type. Okay, I don't want to give you all the nitty-gritty details of what was not possible, was not possible, but almost any type you can put in here as the element type for this vector. Dynamic, essentially is dynamic dynamic array. The size is dynamic. So because we don't know how many names we're gonna get, we're gonna need the names from the standard input. Let's say this is what we're doing here. So we need to put them into this vector. Then we also have a string variable here, and this input name obviously is an empty string. When you do it like this, it's not like it's indeterminate value. It's not indeterminate value like a fundamental type would, but this is going to be an empty string, and that behavior is defined as one of those constructors. Okay, let's see if we can look at this. Now take a look at this, right? Actually, this is the, well, have to look at the standard version. That will be over here since C++20, right? So you just have a constructor that takes no argument. Okay, that would be the default constructor. So that's what's going on there. So again, that makes an empty string. Now, here what we're doing is we have a forever loop, and to read words from the command line, we use this get line. Now, this is a get line function that's defined in that string module. And so we get line, take a whole line of words or whatever you put in from the standard input, the character input, and then put this into this string. If it's empty, like you did not put anything, that will means we're gonna break out of this loop. Okay, so it's a forever loop. Don't be afraid. You have a way to get out of it. So this is how you get out of it. If you just not putting anything in there, you just tap and enter, and then that will terminate. It will finish this loop. Otherwise, it's going to read that name, put that into the vector with the push back. Now push back means to push the value to the back of the underlying array, or the back of the vector, okay? So here there's a little algorithm to sort. This is like a bubble sort, not super efficient sorting, by the way. So I'm not going to get into details of how to optimize an algorithm, and that's not the focus of this course. let me know if you're curious, you want to know more, and that again. So I want to mention one thing here. There's a swap function that's being used. It's of course the swap is used on now. Remember this names is a vector, right? Vector again, as you notice here, this vector also supports this subscript operator, like what we saw for string, right? So you see a lot of similarity with the containers. Um, and this is getting the ith index element, the ith element of that vector. And then, of course, the element types are strings, right? This is the element type uh, in that angle bracket. And so that is a string. And so we're invoking a swap function on that string. You see that uh, pop up here from the IDE. That is, see the scope, std colon string colon swap. So that's the member function for string. And then what it does is it swaps the content with another string. And that swapping is very efficient. Okay. So, and this is a fundamental operation, by the way. You'll see this almost everywhere because when you're operating on things, and this is one of the things you may do. And here, let's kind of look at what else we've got. We can find the length of the longest name. So we're using a range-based for loop here. And then you'll notice we're using a const reference. Then you're also using the automatic type deduction from compiler will figure out what the type is. Obviously, it's a string, so compiler can figure it out. So we don't want to type. And this reference allows us to modify typically. Of course, when you declare this as a const reference, that means you're not modifying, you're only reading only. And this is efficient when you compared to not using the reference. If you're not using the reference, you're doing a copy of what are the value that's in the vector, and then you're copying that value out into this variable. Versus using reference is like a pointer, remember? A reference, but it's an alias. What really the technical, it just means is you're creating an alias. We're not doing any copy, so it's very efficient. So this pattern you'll see a lot. Use a const reference to loop through something if you're just doing the read only. Okay. What else is new here? So here you see this format specifier, right? So we study this format specifier here. We don't have the positional index for picking which the argument will be matching which specifier. So it will just goes sequentially, right? Based on the order in that string. Now, so here after the colon, we have a specifier here. There's also another pair of braces inside. And of course, this position, based on, if you still recall the format, general format, and then this is alignment, right align, right? And right after this, you may have the width of the field. So the field width, and here we're actually not using a number, a constant number here. Here we're using something that's coming out of a variable. So we're passing that in. So this gives an opportunity to format your string output in a dynamic fashion. You can do something really interesting here. Okay. So this is a usage that is allowed. Okay. We did not explain this before, but this is allowed. And that's what I wanted to say about this program. Let's go back to slides. So, of course, what is the purpose of string? The string is, symbols. They help communication. We use this strings. We read books. They're all just strings inside, right? And then we write a program. The program is full of strings, right? This is all. And this world has so many different languages, and not everything is written in English. Not everything is right. There's hundreds of languages out there. And so, of course, there's thing, and the person I mentioned about the locale is the concept in computer, in the computing world, we are capturing different facets of a culture into a thing called a locale. And that locale typically is represented by a language, a primary language plus the region. Even with this, for the same language, okay, like for example, English, right? American English is different from British English and different from Australian English. And not just the language, is different. Sometimes even the formatting of numbers, of currency, of dates, those things could be different. This is what the concept of locale is. So when you make a software, your software may be sold into different countries. So you have to take care of, when somebody purchases your software, let's say from, let's say Germany, perhaps they prefer to see all the words from the software in German, right? So that's the idea of, so you have to design your software to be ready for the international markets, and that is the idea of internationalization. It's a long word, so normally we just shorten it to call it IATN, and so it's software design that accommodates various languages and regions. It's that idea of designing your software so that it's capable of handling different languages and regions. And then that means, for example, you don't want to just have a hard-coded English string inside, and that's called, let's say you're creating a desktop app, you have a file menu, you just have a word file in your program hard-coded. That's not going to work. It's not ready for internationalization. It's not ready for other languages. So you can't do that, right? If you really care about it. Then there's this idea of a localization. This is a related concept. Localization is a shorter word, but still relatively long. So sometimes it's shortened as L10N. And localization is the idea of, for example, translating the strings that you actually use in your program into a specific language where the user prefers. They say the German user prefers the German language for your software, and so you have sort of maybe a resource bundle that contains the localized translations of the things that's displayed in your software, for example. Right, that's just one aspect of localization. Of course, when I talk about the numbers, right? Formatting of numbers, formatting of a currency, money, formatting of dates. There's all kinds of stuff, and even color could mean different things. The red color, right? Here in the United States, as an example, the red color means it's like stop, right? No good. But then in China, red means it's good. It's auspicious as color. So see, the, there's different things that you have to take care of. Now, that's localization. Now, the thing is with the C++, the standard library, unfortunately, for so many years, just whatever reason, it hasn't got too much attention. Um, it's like crippled situation. The standard is not good enough for this localization purposes. Still inadequate. It keeps adding stuff, like it added a bunch of new fundamental types, right? The char 8 and char 16 and char 32. Fine, that's great. They've been lacking for a long time, by the way. People already had the need, and they have invented all kinds of solutions out there. And so even with those things introduced, it's still lacking so many things. For example, the CL does not support the char 8, char 16, char 32, and then what's the point? There's a lot of things you cannot do. And so that is the situation right now. Perhaps it's going to change a couple years later in the next major version. Who knows? Okay. But right now, if you need it, what you do, you have choices of a well-known libraries, battle tested. So one of them is called ICU. Now it's short for International Components for Unicode. ICU maintains libraries for different language bindings to deal with, precisely localization issues. And so the only issue with ICU though is it originated, I think it started with a Java library, and so it's got really good Java library, but then they ported this into C++, but they're not really using too much of a C++ EDMs or the patterns that feels natural to C++. So so the library doesn't feel very good to use, but you can use it, of course. So there's a bit of downside. Then the other option is a boost. Boost is actually a collection of libraries. There's many different things that it does. Now, one of the libraries in Boost is called locale. So the locale library in Boost um, provides a modern C++ interface, and it has a sort of like a plug-in mechanism, and by default, it's going to use the ICU. It's because ICU is a feature complete, right? It's really good, and for so many years, despite the fact that it's a little outdated in terms of the C++ interface. So that post locale gives you a nice C++ flavor to use the localization features, um, and so that's what I personally would prefer. So this is actually an example. I'm just going to show you how you might use that. So actually, let's take a look at an example right now. And this example is the one that I recorded another video to help you build it, because this introduces a new library, the Boost. Boost is a large library, and then the installation, of course, differs between Mac and Windows. So I have provided that video to show you how to do that. If you encounter problems, please let me know and post your issues and questions in the discussion board. All right. So suppose you got everything ready, and let's look at the code. And just there's a few lines of code just to illustrate a few things. And so of course we got some headers to introduce the functionality from Boost. So let's say we got the locale here, and we have some utilities for conversion, but we'll see. So first of all, a couple of new things here. Well, not that's new. I think we have seen this before. I just want to show you how we may typically use them. For example, the standard namespace that's got majority of the stuff from the standard library, right? You don't normally you don't want to just introduce all the names from the standard namespace. It's going to pollute your local, whatever you're working on, because standard is going to choose whatever the words is appropriate. Um, Again, that's the whole reason why we have the namespace is you can choose the words that is most appropriate. You don't worry about naming collision. So you don't necessarily normally want to sort of introduce all the names into your local scope from the standard. And instead, if you're doing a lot of the CL or end of line, right, then you could potentially just introduce them so you can write them without this std prefix, right? This with the namespace scope. So that's just an example of what you might consider doing sometimes. And then here's another thing here. This is the declaring a alias namespace. So you have this boost names locale namespace. Is if you're writing a lot of the types here and that's too much of typing, and like looks long. So I just made a alias here and called locale, right? Because the context is clear, and we're gonna just say this is from the boost locale here. And there's a thing called a generator. This is actually used to generate a locale. Remember the concept of locale we're talking about, and we have used some of those case conversion functions instead of using the. If you look at the examples that I have changed the places where the book uses the C type header, basically the C style way of those functions. I've use the C++ version. Typically, try to avoid the C style programming if you're writing a C++ program. And so anyway, so it's the concept of locale, this particular class, this object. So, so as you see, the standard has bits and pieces of the solution, but not the whole solution. So this, of course, the library, the boost is still, of course, using those bits and pieces that's provided by the standard, trying to be as much standard as possible, of course, not to reinvent the wheel. And that concept of a locale is certainly valid as an abstraction over all these cultural differences. So as an example here, we have this string. Even this string is actually standardized. And then you can look up for what, like for example, EN_US, that would be English for US region. So you have seen things like that. And also we're adding a character encoding here using the UDF-8. So there's UDF-A, UDF-16, UDF-32. By far, UDF-A is the most popular. So when in doubt, go with UDF-8. You're not going to go wrong with it. So this is the locale for Chinese China region. Okay. Now, as I said, the Chinese is spoken in Singapore, it's spoken in Taiwan, it's in Hong Kong. They all have different things, different cultural aspects. So they will be having a second element. This is the country code to indicate, right? So this is kind of captures the essence of a locale. So here we're setting the global. This locale, we're going to use this. Let's say we're using this throughout the program. And so globally, we're using this locale. And then we're imbuing this locale to this cout stream, this character output stream that ties to the standard in, standard out. And so that when you use a cout to print stuff out, it's going to always use this locale, right? So that's the locale setup. And then here, let's do some, make some operations that's locale specific, right? So for example, we got some German words here and Grusen. Well, they'll have a German word Grusen, and then we have a Greek word Odysseus, right? So from Homer. This is Odysseus in Greek. Now, so the upper, so we're just testing. There's this using the boost locale to turn these words to uppercase. As you'll see, this character, this particular character looks like a beta, but it's like again, this is a character in the language, and then when you do the upper case, it's going to be looking kind of different. Okay. And then we have a lowercase for the Greek word, and then we're contrasting with the standard version. So basically, if you're using the standard library, this is delegating to the standard library to do the uppercase, lowercase. This is, you'll see, they're not being done properly at all. So that's why I say the standards are inadequate. And we're gonna just print this. We'll run this programming in a second. So let's go through this next one. For example, this has a mechanism. Is basically remember we have used these stream sort of the stream flags, the modifies the stream behavior. So those are actually setting a flag on the stream. And so here we have special a special flag called a spell out. This will spell out the number in the local language. Okay, like when you're writing a check, right? You're writing a 12,000, right? Just in the English letters, right? English words. So similarly, in this case, we're doing the Chinese here, right? So you'll see the Chinese spell out of a number. And then the date format also is different, how the things are formatted. And see this date, whether so we're getting tomorrow's date. And then you'll see that the locales has some nice date time manipulation library. So you do it now, is this is the time right now plus another day. So that will be tomorrow, same time. So we're printing this out in Chinese as well. So the stream manipulator date changes the flag on this output stream, and then we'll do that. We'll output that thing in Chinese as well. So if we run this program, you'll see this is a kind of the idea of a localization, it's the difference in a particular language and a region. So I think I've already built it. I mean, again, it doesn't hurt if I want to build it again. And it will just say it's up to date. If I built this before, oh, I did not. Okay, good that I did run the build. Well, it's actually up to date, but it's trying to upgrade, checking the status of other things. Okay, it's fine. So now I have the program. Let's run this thing. Lecture C, C, another C. Okay, that's the program. So see, here's the output. You make this bigger. So the original word Gurusan, and then you have this uppercase. This is a German word, and then you have the standard. I see the standard doesn't really handle this properly. It does not understand how to capitalize this character. And this is a Greek word. Odysseus. Odysseus gets lowercase like this, and it's interesting if you look at the this like a sigma letter. It's kind of translated in a lowercase differently. Lower sigma versus the very last one is like this. It's kind of contextual. Okay, so it has a lot of complexity when it comes to even just casing. And the standard is not doing this well. Actually, it's not doing anything at all. You see that? It just doesn't understand. And then here's the Chinese spell out of this number, 12,345.6. And then this date, tomorrow's date, this is the date. You have the year, and this means year. You have the number represents month, and then this means month. You have the number 14, that's the day of the month. And then this last word here means the day. So again, localized. Okay, so this is what you want to show to your customer if you're shipping the software. Okay, now let's go to summary. So the string type stores a character string, or you can think of this as a character sequence. This string is like a container, almost like a vector. So think it that way. So yes, in fact, it's very similar to a vector of a char. There are some subtle differences, of course, but again, the string is tailored for string, the string operations. I mean, the vector really doesn't care what you put inside. It's just going to do what it's going to do. It's very generic, but the string obviously is one of the most common things you're going to deal with in a program. So that deserves a special type, and then it has different optimizations for strings. And the string also maintains a C-style string internally for compatibility, and then you can actually retrieve that internal C-style string, no terminated, through the data or C_string functions. The plus operator is used to concatenate. So we kind of redefine the meaning of that. So you use that same symbol that there's a built-in operator, right? It's for the addition of basically numbers. But then here for this custom type, this data type, a string, and we're defining this to say you use this plus for concatenation. Now, keep in mind though, for the concatenation, you have to one of the operands of this plus has to be a string object for this to take effect. Otherwise, you're not dealing with a string type anymore. So objects of a type W string, that contains strings of characters of type W char or Y char. So that's expected. The objects of type UN string, N could be A1632, contains strings of characters of type char N underscore T, and that's char type, char A, char 16, char 32 types. And now these are the sort of the things, the bits and pieces that is provided by the standard to deal with, like a Unicode and things like that. But it's still pretty inadequate. There's a lot of things it has not provided. So that's why we may go to a boost locale to deal with those things. Okay. That's what I have. Okay, one more thing. Just the internationalization, localization. Yes, as I was saying, the standard library is inadequate. Okay. That's it. Thank you.